Hello, I think we might be live. I will give everyone a couple of minutes to load in before we get started. In the meantime, how was your day, both?
Yeah, good, Tori. How are you?
All good, all good. The football's on, so this was poorly timed, this stream. If you're an England fan, I guess. Or a Denmark fan.
No, I would have chosen this anytime. Awful. How are you, Luke?
I'm good. Same old. Missing the football.
Yeah. Oh, nice. Is it good weather? Oh, I've just pulled out the weather line, but it's nice and warm here. I know you're very further up north.
This is broadcasting to a screen in my local pub.
And I'm really excited because this is our first first user group that's going live today. So I'm super, super excited.
Good stuff. Cool. We'll have a couple of minutes. We should be streaming to both YouTube and LinkedIn. Yeah. If anyone wants to leave a comment, if it's not working, I guess. If not, we'll give it a couple of minutes.
Oh. Alex is
Hello.
here.
Okay. We can at least safely say that YouTube is working. Oh, LinkedIn works.
Hey, good.
Woo. All right. So the technical difficulties are out the way. Everything now should be smooth sailing. Cool. Do we want to start? It's 3 minutes.
Yeah, I think we can kick off.
Let's jump in. Cool. All right. Well, thank you everyone for joining. This is the Global AI UK very first meetup. So, yeah. So super exciting for us. Hopefully we do this every 3 months, the plan. So 4 times a year. Have a bit of a mix of streaming and in person, hopefully. But yeah, so welcome everyone to our very first meetup. So I will get us started with a bit of an agenda. So before we start, it might be nice for you to all meet us. So we run the UK meetup. Gavi, did you want to introduce yourself a little bit?
Yeah, sure. I'm Gavi. I'm the head of AI at Advancing Analytics, but also a co-host of the Global AI UK. I'm an AI MVP as well as a Databricks champion. And yeah, that's a quick kind of introduction of me. I'm going to pass you on to Luke.
Hello, everyone. I'm Luke. I'm a principal AI consultant at Advancing Analytics. Been in the world a bit, so started off doing a PhD in nuclear physics, then moved away from that to bins, and then found myself here. That's pretty much me.
Thanks, Luke.
I'll pass you back over.
Thanks. Yeah, I'm Tori. Also with AA, Advancing Analytics. I'm a senior AI consultant. Co-host. Also do a little bit of podcasting, bit of charity work as well. But yeah, that's me. Thought it'd be nice for everyone to see our faces just the once, or at least for the first one. But if you want any updates on the meetup, then it's always good to follow at least one of us. I think we all post quite often to LinkedIn. So yeah, follow along. Cool.
I'm intrigued, Tori. You say you do a bit of charity work. You don't do charity work for Advancing Analytics, surely?
I mean, Advancing Analytics isn't my charity work.
That's it.
If that's what you're asking.
That's what I was asking. You do a bit of charity work. I'm like,
Spending time with you, Gavi, is my charity work. Yes. So cool. We do have 10 minutes before the first talk starts. So it might be nice to go through the talks we have today. So we do have our very own Gavi doing the first session of the first meetup, talk to us a little bit about Azure AI Studio. And we also have a guest. We have Alex Billington with us talking about RAG with Azure OpenAI as well. So Gavi will be on at 1:15, which I realise now that I was never going to fill up the intro for 15 minutes. Next time I'll make that a 5-minute intro. And then Alex will be joining us at 7. So we've got 2 great sessions on. Yeah, so we've got a little time until you kick off, Gavi. So
we do. I mean, I'm happy to kick off because I have a feeling my slides are going to take slightly more than 45 minutes.
Yeah.
Or we can talk about, what we think the trends are at the minute, what the back of build. Yeah, either way, we can either get started or we can.
I like that. What was your favorite Microsoft build announcement then?
So Microsoft build feels like ages ago, and since Microsoft build, we've had the Databricks Summit as well, and things are progressing along, especially in the generative AI field. And I think what's coming up is agents, right? Agents. It's all about agents. That's what I'm hearing lots more and more and more. But and that's what I've said all along. I think agents will start to develop and mature to a level that we start incorporating and implementing into frameworks. And I think it's hugely, hugely exciting as well.
Yeah, I remember you mentioning, I feel like it was about a year ago now that agents were going to be the next thing. And I was like, yeah, sure. And then sort of Build announced their the Azure OpenAI agent assistance API, that's what it's called. And then was it last week we had the Databricks keynote announcements as well, and they had their own flavor of agents as well.
Absolutely. I think in Build as well, there was, a couple of talks on AutoGen and how you use AutoGen and how people have been implementing AutoGen, which is all about agents. And AutoGen is Microsoft's framework to implement agents. And that's come along leaps and bounds. And I've got a question on the chat here, Alex B asking what my thoughts are on AutoGen Studio. Now, I used it when it first came out. I think it's version 2 now, or it might be even more than version 2, but version 1 certainly was exciting. But I'd say it's not quite there yet in terms of using it for development work and productionizing agents. What is
AutoGen, Gavi?
AutoGen is Microsoft framework to implement agents. So pretty cool. Have a look at it. There's a whole GitHub repo. There's a whole kind of documentation and instructions in terms of how you start using AutoGen, how you use it, all the different use cases. Super cool. What I'd say is allocate sufficient amount of time, because you're going to get sucked into reading it like I did and spend 3 hours just understanding how you do it, playing around with it, because it's super, super exciting as well.
Oh, good. Sounds like a future.
Next talk?
Yeah.
No, next talk, like you're going to be talking about. I'm going to play
That was my dramatic pause. You ready?
Yeah. So I think I'm super excited to see how that evolves. What about you guys?
Favorite announcement from Build?
Yeah.
My favorite, and the stuff that I've already kind of gotten stuck in with, is the API management,
Yeah.
OpenAI integration. Yeah, I think it's setting up leaps and bounds towards LMOps or FMOps, your kind of preference of terminology there. Yeah, just load balancing, caching, all of that stuff in APIM. Yeah, I was most excited about that.
Yeah. What about you, Luke?
Is it a bit cheeky if from the Data and AI Summit, I'm just relieved that Lakehouse monitoring is finally into GA.
Oh, right. Yeah, of course. Yeah, that makes it a lot easier in terms of monitoring your models in Databricks.
Mm-hmm.
I've been waiting for ages for that.
Yeah.
Cool.
Exciting. Anyone in the comments got their favorite announcements from Build or from the Data and AI Summit? There were tons, really, weren't there?
Yeah, there were loads. I think what's coming up as well is the use of small language models. We've seen with 5.3 with multimodality. That's been really, really effective and really cool as well. So there's a lot of things that's coming up, all to do with AI and generative AI, which is super exciting.
Yeah, and good timing because we have 2 Gen AI talks today.
Yeah, exactly.
We didn't do that on purpose, but works nicely. Yeah. Cool. We've got 3 minutes. Hopefully we'll have a few more join and then we can get you kicked off, Gabby.
All right, cool. Very good.
This is the time when in a traditional meetup you would be getting your beer. And that's probably why I gave it 15 minutes. But note to self, next time the intro only needs to be 5 minutes, so it's not 10 minutes of awkward conversation on air.
Awkward? I don't think this is awkward.
Have either of you ever played about with stable diffusion models?
Is Mid-Journey not the right thing to say here then?
That probably doesn't count.
No, I've not played
Mid-Journey is cool though.
No.
Yeah. I've noticed since you acquired the license recently, there's been more embarrassing pictures appearing on the company chat.
I don't know what you're talking about, Luke.
Yeah.
But anyway, it'd be good to also ask our audience who've joined us today in terms of, has anyone used AI Studio before? Has anyone heard of AI Studio? Is anyone using it actively to develop large language model applications? It'd just be cool to understand what people are doing with AI Studio, or if they've not heard of AI Studio, then you're in for a treat. But if you have and you've been using it already, it'd be cool just to see some comments come through in terms of understanding what people are using it for.
Yeah, and while that's going through, I think should we set up your slides, Gabby?
Yeah, absolutely. Yep.
Make sure they're working all right. Cool. Let me remove mine.
Okay.
Sorry, it's like a racetrack outside my window. I will move myself. Awesome. All right, it's going to tick over till 6:15 any second. So me and Luke will retire backstage and you take the floor then, Gabby.
All right, cool.
Right. Thank you.
All All right, we're bang on time now, so I'll get started. The title of my talk today is all about a beginner's guide to Azure AI Studio. So if you've not heard about Azure AI Studio, you're in for a treat. However, if you've heard about AI Studio, there might be certain elements throughout this talk that you just pick up on and try and implement it and use it and find it useful. So what's AI Studio, right? AI Studio offers a unified platform to all large language application developers out there that are looking to develop generative AI apps, right? And it provides, for data and search, for example, capabilities. It's got a catalog of foundation models that you can pick and choose from to start developing your large language applications. And Microsoft, as we know, are very, very hot on safety and responsible AI. So they've baked in a lot of the safety and responsible AI within Azure AI Studio. And we'll talk a bit about it as well. And what I love about Azure AI Studio is how it allows developers to use prompt flow, for example, to develop an end-to-end life cycle of LLM applications, and also gives you the ability to do LLM ops and model monitoring. So in terms of providing a unified platform, Azure AI Studio is pretty good, and you'll see through the demos that we have that it gives you an entire end-to-end experience to develop generative AI apps. So let's start off with a quick demo and an introduction to AI Studio. And if you click on AI Studio and when you start it off, this is what it looks like. I've got a little demo that's recorded that I'm going to play. What you see on the left-hand plane is a load of options. What you can do is go to settings, right? And within settings, you'd see all your information about Azure AI resource, the connections you have with AI search, for example, the compute instance you're running, what runtimes you're running, and all the information. Even if you have project members working on the platform, it gives you all that information. What it also does is gives you the ability to look at your deployments, deploy models. Here, what we're doing is deploying a DaVinci model. But the playground is pretty cool, right? So you can play around with large language models here. You can type questions, you can get answers, and you can experiment with different models. You add your data functionality, which we'll see another demo for, is pretty cool. You can bring in your data specifically to Azure OpenAI, and you can ask questions according to the data that you bring in. So we'll only answer questions based on the data that you're embedding into your Azure OpenAI Studio. So here, what we've got is we're going to be quite cheeky here. We're going to ask a question in Greek, which I think is pretty cool. And you'll see here, right, immediately, it's got the functionality to understand what you've asked, even if it's a different language, and it's capable of giving you that response back in English. Your system message gives you the flexibility to change your prompt, your system messages. So, for example, here I've said you're a friendly and funny. Everything that comes out of the answer should be friendly and funny. And as you can see here, it does exactly what you've asked it to do. Now, what's cool about Azure AI Studio as well is about having to do your manual evaluation. You've got lots and lots of different functionality. I know I'm going through this quite quickly, but we have demos after these slides that you'll see later on as to how we carry out manual evaluation. That's a pretty cool feature, especially when it comes to large language model and you wanting to know how each model is performing. You can come into your Azure AI Studio, you can evaluate, you can put in your own data set, for example, and depending on what you're doing, you can get your AI Studio to help you evaluate your large language models. So what I like, the cool thing about here is you can even go through a manual evaluation and you can put a thumbs up if you think you agree with the evaluation and thumbs down, and it will tend to show you the stats at the end of it so you know exactly how your model is performing. Right, so that was a quick introduction to AI Studio. And what we're going to talk about next is data, right? How we connect data, how we use the functionality of data and search within AI Studio. Now, we all know data is a fuel that powers AI. If you don't have data, there's absolutely no point building large language model applications. And it goes back to sayings that you've probably heard, right? Garbage in, garbage out. And it's so important, especially when it comes to large language models, you feed in good data and good quality data so that you're going to get something that's good quality on the output as well. And what we find, and we've worked with quite a number of applications, large language model applications now, the most common problem with customers and large language model is that the data that they're feeding into large language model is often poorly formatted, very unclean. And what that leads to is subpar outcomes, right? It's terrible outcomes. And then they blame the large language model. So what I'm really trying to say here is data is really important. And what Microsoft has done for us has given us the ability to connect all your different data sources out there. And the great thing about it is it gives you the ability to integrate structured and unstructured data. Okay. So here, as you can see, we've got, blob storage. You've got loads of different options. And the goal here really is to make sure whatever you're giving in as an input, you have the ability to do what you need to do. And we'll talk about it in the next slide to feed into large language models. Now, when we talk about large language models, what comes down to making sure your input is clean and processed, and you're feeding it to your large language model. It all boils down to how well you chunk your documents and the embedding model that you use to embed the documents. So what do I mean by chunking and embedding? So here on my slide, I've shown a slide. This is the big book of MLOps that I've taken as an example. And chunking is merely, as the word describes, dividing the text into chunks of, you can choose different chunks. Like say, for argument's sake, you're going to divide the chunks to 512 words. And then what you have to do is you need to convert it to a format that your computer understands, right? And this is what embedding does. So embedding, what it does is it takes a series of texts, it converts it into a vector of numeric values, and then it stores it in a vector store. And the reason why it does that, it can do searches across numbers more effectively than text. And one of my favorite diagrams that I go to understand how embedding work is this diagram that you see on the screen. So what you see here is a couple of words, right? You've got cat, kitten, dog, houses. They are text, but what you can do is use very good embedding models that are available out there to convert your text into numeric. So for example, here you've got a cat that converts it to a vector of numbers, and that then gets stored into a vector database, right? So if we came along and did a search, for example, queen, that would then look into your vector database and it will do a distance check because it's all converted into numbers and figure out queen is very closely related to king, and therefore it should be related. So in general, that's how chunking and embedding works. Chunking and embedding, it doesn't just end there in terms of developing large language model. When you have chunking and embedding with the documentation, you often are relying on vector searches. So you're storing all these documents after you chunk it and you embed it into a vector store. And what you need to do is do vector searches, right? So within Azure OpenAI Studio, that is such a really cool one. You've got a couple of things, right? You've got vector search that just looks at a series of vectors and gives you the closest vector. You've got keyword search that tends to look at your database and extract the closest keyword. And then you've got re-ranking as well. So there's lots of different options within Azure AI Search. Now, as you can see, what that plot shows on the right-hand side is the hybrid and semantic ranker that's available in Azure AI Search is very good in terms of giving you high quality outputs compared to all the other searches, right? So if you're doing a hybrid, if you're doing vector, you're doing keyword search, it's not as good as if you were to use the hybrid and semantic ranker within Azure AI Search. Now, these results have all been benchmarked against the same documents they were chunked in the same size as well. So here, for example, they were all chunked using 512 tokens with 25% overlap, and they're all using the same embedding models. So it's showing comparison of like for like. And again, just to reiterate, if you're doing an AI search, if you're doing a search within Azure AI, it's highly recommended to use the hybrid and semantic ranker to get you very good results. All right, so let's have a look, right? We spoke about how you get your data, how you chunk it up, how you embed it. Let's look at how you can add your own data into Azure AI Search. So for this, I've got a little demo here. To do this, you click on select your data. You can upload your data, so you've got options here. Here, what we're showing is we're uploading a series of markdown files. We simply select all those files and we go through the options. For good housekeeping, you want to give it your name so you can identify it easily. And here what I'm doing is we're just checking whether the markdown files is exactly what I anticipate it to be. And then what I'm going to do is create an index from all the markdown files that were uploaded. So for this, it's quite a simple process. As you can see, it's you simply click what search you want to use. You've got an OpenAI resource that you can select. And then what you do is you go through the next phases and you give it a name. So an index name here for good housekeeping, give it a name that you can recognize. And it's as simple as that to create an index of all the documents that you uploaded. So here what you can see is the workflow in terms of how Azure AI is going to start taking all that documents. It's going to chunk it all up, generate your embeddings, and then give you your index at the end of it. And once it does that, you can come and test it out by adding your own data. So to do this, what I'm doing here is just selecting the data source. What I'm going to do is point it towards the index that we just created when we uploaded all that markdown documents. And for this, I'm going to select an embedding model. And it's simply as simple as just going through the steps here. Now, this step is all about mapping your data fields. And then here you've got the different search types that we spoke about. Like I said, hybrid and semantic is going to be your best performance. So we're going to select that. And it's as simple as that. You can now talk to your documents that you've uploaded and you've indexed in the playground. So here, what we've done is we've asked a question about products that are suitable to use in San Francisco. And what I love about this is it gives you all the answers, right? But not only that, it also gives you the references as to where these answers have come from. So, for example, here, you can look at the answers that have been provided have been referenced to that particular markdown file. So you can even click on the markdown file and you can go and investigate to just verify and validate that it's exactly where it's coming from. So that's really good. All right, just read through that. Okay, so we've spoken about how Azure AI Search offers a unified platform, how you make sure your data is clean and structured, it's been chunked and embedded into your vector store, and how you do AI searches within Azure AI Studio. Now comes the fun part, right? Now comes to the part of foundation models. Now, what does this mean? Now, within Azure AI Studio, we have a choice of many different foundation models. So, you've got your GPT-4 Turbo, you've got your multi-model large language models here as well. So you've got your GPT-4 Vision, you've got GPT-4o, which is recently released as well, which is very, very cool, very fast, very performant. And you've got loads of different models that you have as options to start developing with and using. Now, what I'd say is within Azure AI, there's lots of questions around, is my data secured? Is my data safe? Is OpenAI using my data to retrain foundational models? And is my data protected? And the answer to all those three questions is it's absolutely yes, yes, and yes. So your data is your data. Your data is not used to train any foundation AI models. And your data is protected by Microsoft enterprise compliance and security controls that they have across Azure infrastructure. Right. Okay. So now moving on to quite a fun topic, RAG versus fine tuning. Now we get this question asked to us quite a lot. What's the difference? When would you use RAG? When would you use fine tuning? Now, just for context, RAG stands for Retrieval Augmented Generation, and that is pretty much what we were talking about, right? That talks about how you incorporate data directly into your prompts without retraining your models. Now, RAG is very efficient, very cost-effective, because you don't really need to get a model, you don't need to fine-tune it, you don't need to redefine weights. It's relatively quite straightforward process. And what you saw as a demo that we showed a couple of slides ago, that's effectively your RAG process, right? So by taking your documents, uploading it, indexing it, and doing searches around it. Fine-tuning, on the other hand, requires additional compute, for example, to adjust the model weights. You need very, very good data. You need lots of good data as well to do fine-tuning. So it's slightly more advanced. It's more expensive as well. But you've got options to do both in Azure AI Studio, right? And one slide that I like to share is, when do you choose between these two techniques? When do you choose whether you're doing RAG or fine-tuning? And the way we do it is we've got a series of questions here. So whether, for example, do you need external knowledge requirement? And if you need external knowledge, then you probably want to be using RAG. Whether, if you've got a model that you would like to change its behavior in terms of its responses, you'd like it to respond in a certain way, then you're probably looking at fine-tuning. In terms of hallucination, now RAG definitely minimizes the hallucination. It never ever gets rid of hallucination, but it minimizes hallucination, and it also provides you with different ways of trying to validate and be comfortable with what's coming out of the large language model. But like I said, it doesn't ever get rid of hallucination. Fine-tuning, it can help reduce hallucinations to a certain extent, but if you don't have enough data, it's going to fall off the edge, and it's going to act exactly at how a normal, pre-trained large language model would act with a lack of data. So here we've got a series of questions and criteria that we assess whether we choose to do RAG or whether we choose to go down the route of doing fine-tuning. And like I said before, Azure AI Studios offers both RAG and fine-tuning for whatever applications you wish to develop. Okay, so let's talk about all the different models that's available within Azure AI Studio. And like I said before, you have options to use loads of different models. Here we're looking at Azure OpenAI models. You also have the option to deploy Hugging Face models, for example. There's over thousands of different open source models that's available to you within the model catalog. More recently, I think you've got 5.3 as well available in your model catalog. So if you're wanting to play with those kind of models, you can go ahead. You can look at your catalog option, and you can simply deploy it and start experimenting with those things. Okay, so we spoke about model catalog, but we've also got the other bit of option of model as a service. The model as a service is a step further, right? So what it does is it manages the entire infrastructure for you. So what it does is it pretty much, you can deploy, for example, Mistral's premium model or Meta's Llama 2 model, and Microsoft looks after all the infrastructure, and it just offers you the API. And the way you use it is you use the API as pay-as-you-go billing based on the tokens that you're using for that particular model. It's quite cool. It's quite easy. It's a couple of clicks. I think maybe 3 clicks. You get to use all these cool different models, and it gives you an easy way as well to integrate it, whether, if you're using prompt flow for orchestration or semantic kernel, or whether you want to do more of a backend development using LangChain, that has the flexibility as well. It gives you loads of flexibility. And what you can do with model as a service as well. So for example, you can deploy Llama 2, and you can also go the step further of fine-tuning Llama 2 without provisioning GPUs, which is honestly quite great because it's quite hard to get GPUs at times. So model as a service gives you that flexibility to do all those things that I've spoken about in terms of deploying a Llama 2 model, without having to worry about the infrastructure, without having to worry about spinning up GPUs. And the aim really here is to provide all of us, developers, customers, to integrate as many AI capabilities into your application. Okay, so within Azure AI Studio, we spoke about all those different models that's available to us. How do you know which model to use? How do you know which model is going to be better than another model that's out there that perhaps you've heard of and you're experimenting and you're not really sure as to which model to use? So we've got model benchmarking as well within Azure AI Studio, which is pretty cool. And we can see in the next slide, I've got a little demo to see just how you would use model benchmarking to decide in terms of if you're doing question and answering, for example, as a task, which model would you choose? Which model would you select to implement for your development? So let's have a quick look at the demo. So this is model as a service. Let's have a look at model benchmarking here. So here, what I'm doing is I'm going on to the Explore and looking at benchmarking. You've got all these different models. Like I said, if you choose question and answering, you can select all the different models that you wish to use in your project. And what you can do then is compare those different models. And what it will do is plot it as a benchmark for you. So it gives you a really clear idea in terms of, right, I'm going to be using the GPT-432K because it's more performant in terms of score. So let's talk about how you'll deploy model. As we spoke about in model as a service, you can simply click the model that you wish to deploy, and within 2 clicks, you can deploy Llama 2 7 billion model as a pay-as-you-go model. So here, what I'm doing is I'm just searching for the project, and you select the project. The AI Studio then sets up and looks after it for you as a project, and you simply click subscribe and deploy, and it does all the backend stuff for you. So it's deploying all the infrastructure and looking after that bit for you. And it's pretty much that quick and easy to get a Llama 2 7 billion model deployed within your model as a service. So here, what you're going to see is you're going to see it being creating. The endpoint will be created. It takes a couple of seconds. It can take a couple of minutes, but that's it. You've got the API key. If you want to develop it in your backend, you use the API key. If you want to test it, you've also got the functionality of playing around with it in the playground. Like I've just shown. Now, what I'm going to show is how you do fine tuning. So we deploy Llama 2 model, but what we want to do is get Llama 2 model and we want to do some fine tuning, right? So here is exactly what I'm going to do. I'm going to use for housekeeping. I give it a good name, and it's very simple. What I'm choosing is a task type is text generation. You can upload your own training data, which has to be in .json format. And when you do that, what it then gives you is it identifies your JSON, and then you're simply mapping the fields. So you've got to make sure your prompt column is mapped to the exact column that you've uploaded. And then it's a matter of just clicking on next. And you've got validation data, right? Because when you're fine-tuning your data, you need to validate it to see how accurate it is and how it performs. You've got a couple of options. You can either split your training data set, or you can, if you've got your own data set, you can choose to upload that like it's showing here on the demo. And again, it's simply you map the relevant data columns to the fields. And it's as simple as that. Now here, you're just telling it, your learning rate and epochs. You tend not to change that anyway. You tend to go with the default. And it's as easy as that. As simple as that, you've now created, you've got your training data set, you've got your validation data set. And what it's going to do is deploy your fine-tuned model. You can have a look at the metrics in terms of evaluating how good that particular model is doing. And it's got loads of metrics for you to decide. So this is going to help you decide whether you need to go and choose another model to fine-tune, or whether this model that we fine-tune is good enough to go. And what we do now, we can deploy it. So you get an endpoint. So in the previous demo, we showed how to deploy this, and it's the same way. You just give it a name and your method of just clicking on deploy, and your fine-tuned model now will get deployed in the same way as deploying any model as a service model. Right, so here, what you can do now is also test the model that we fine-tuned. in the playground. And here it's just going to do, because it's a text completion that we've trained it as, what I'm expecting here is exactly what you see. It's just going to complete text, and you can do more advanced stuff, but this is pretty much a quick demo in terms of showing you how you use model as a service to deploy advanced models and also to do a bit of fine-tuning. Okay, this is what I showed before. Now, I've got another quick model following that, and it's all about how you utilize the power of multimodality within Azure AI Studio. So what do I mean by that? Let's have a look at this demo. Multimodality is pretty cool. I spent a lot of hours playing around with this. Here, what we're going to show is we're going to go to the playground, and we're going to work with images here. So with images, you can choose DALL-E, which I've spent hours playing with it, and you can generate lots of cool and exciting pictures here that I'm sure you guys have played around with. DALL-E is pretty cool. You can simply put your prompts in, and you can generate loads of images. You can download the images as well, and you can have variations. So yeah, I've spent a lot of time playing around with this. But what's cool about it is in the playground, you can upload an image. So here we're going to upload a San Francisco image here. You can't really hear it, but what you can do is also speak to it. So it can convert speech to text. So that's where the multimodality comes in here. And you can ask it to give you an itinerary of what to do in San Francisco. It recognizes speech to text. It recognizes the image, and it will then plan out an itinerary for you appropriately that you've seen. What we can do as well, which is pretty cool, is if you enable the vision option here, what it does is it taps into Azure AI vision services. And this is pretty cool because what it can do now is it can do image segmentation here for you. So here, what we've done is uploaded the same picture, but you can see it being highlighted now. So if you click on the highlighted link, you can tell where exactly in the image the bridge appears or the skyscrapers appear. So pretty cool things that you can do here, which is quite easy to do. All right. All right, so we spoke about the platform itself, how you would prepare your data, how you would utilize Azure AI Search to do hybrid vector search. We tapped into foundational models, how you use model as a service to deploy your likes of Llama, your Mistral models, and how you do fine tuning. We also looked into how you would do multi-modal large language model applications, so just playing around with it. Let's talk about safety and responsible AI within Microsoft. Now, Microsoft have got these principles for a long time. So even if you're working in traditional machine learning, you've got your evaluation and responsible AI behind your traditional machine learning. Microsoft have done a pretty good job in terms of transferring all those learnings to large language models, and things are constantly being developed. So things like fairness, reliability, safety, privacy, and security are all incorporated into Azure AI Studio. And within that, you've got Azure Content Safety, which is fairly new that you can use to understand your inputs and outputs into your large language model. So if you're playing around with Azure AI Studio, if you're playing around in terms of developing large language LLM applications, I'd highly recommend just investigating content safety. It's very easy to use, and it's a tool that we use every single development that we do. Okay, so we've spoken about quite a lot of things now, but how do we put all these together, and how do we perform LLM ops, and how do we do model monitoring, right? Now, Azure AI Studio, as you can imagine, gives you that capability. So it gives you the capability in terms of prompt flow, where it orchestrates everything for you, all AI applications quite easily. Now, I've got a little demo as well, and let's have a look at this demo. So here, what I've got is, again, within Azure AI Studio, we're going to view this flow, and this flow is developed in prompt flow. So here, what you see is a graph showing all the different elements within prompt flow. It's quite easy, as you can see. On the right-hand side, you can go in and change things ever so slightly. You can have many, many different prompt variants quite easily. You can even get it to generate different prompt variants for you, all in prompt flow. And what it does is it gives you lots of flexibility in terms of making sure you've got placeholders in your prompt flow, you're getting all your inputs and outputs, and you can even do a batch evaluation here. So what we're doing here is we're doing an evaluation on the question and answer pass. For housekeeping, we give it a good name so you can understand what you're doing. And what we're doing here is just choosing all your different options, and you're selecting the prompt variants here that you wish to assess and evaluate. And what I love about this is it's got metrics as well. So you've got your groundedness, relevance, and coherence. You can use whether you want to use your existing data set or upload your data set. You've got a choice of doing it. And it's as easy as just, if you're uploading your data set, make sure you map your data sources to column names appropriately. And when you do that, it's as easy as just submitting the job. And in the background, prompt flows evaluating all of that for you automatically and giving you the scores almost instantaneously, as you can see on the screen. So that I found quite cool. I love the metric dashboard because it immediately tells me whether I need to go back and evaluate, do more with my LLM application, or make sure I've got better data coming into my model here. What I love about it is you can choose and pick and see all the different metrics in different ways. So for example, here, what I'm doing is I'm comparing different prompts and looking at different metrics side by side, which is pretty cool. And now what I'm going to do is, if I'm happy with it, I can even use within prompt flow, I can choose to deploy it within prompt flow. So here I'm just selecting my options, and it's as easy as just clicking through the options and going through the stages. And Azure AI Studio looks after all of this for us quite, I would say, very, very easily, right? It does all the infrastructure spin up as well, and it will give you an endpoint like what you've seen now. So what you can also do is, if you get the endpoint, this is what we do quite often, you can test the endpoint to see whether it's giving you an output as per your expectation. If you wanted to consume it and do your development backend, you've got a load of code there to do it. It's also got monitoring to show you how it's been, model monitoring. You can even go the extra mile in terms of saying, if you want certain metrics to be monitored, you can choose what metrics is relevant to your project. And it's as simple as just ticking it, choosing all your column mapping names, and then you create a dashboard that will give you an immediate view of how well your model is doing in terms of monitoring. Okay, in terms of deployment, you've got a lot of different options here. So here we've deployed a couple of workflows, and you can swap one workflow out with each other, which is what I'm going to show. So we've got 2 deployment names, and you can adjust the traffic accordingly, which gives you so much of flexibility if you're testing one deployment, one workflow against the other. And it's as simple as that. Prompt flow is a great tool in terms of developing your workflows, helping you evaluate large language applications, and even going through the extra mile of deploying it for you. I think that is pretty much the end. Oh yes, before I pass the platform on to our next speaker, I'd really appreciate it if you can fill out the survey. It'll just helps us as well deliver more sessions like this. This actually goes back to Microsoft, but yeah, it would just help us put all these kind of sessions to see how handy it is for you guys, whether you found it useful, whether you want to hear from us talking more about generative AI, how you use Azure AI Studio as well. And that's the end from me.
That's my clap. Thank you, Gavi. We have 10 minutes for questions. So if anyone's got some questions, we do have some questions already. We have 8 questions already. So how does Azure validate clean data? And is JSON the only format of raw data it collects?
So I think you're talking about the fine tuning here where I showed JSON. Is that right? I hope it is, because that's what I was showing. If you're fine tuning data, or if you're validating your data and you're uploading your data set, then yes, it's JSON format.
Awesome. Cool. So next question. Is there a publish option for testing in real time?
Oh, that's a good question. I'm not sure. I don't think so. I don't think so. I'm not sure if it is, but I've not seen a publish option for testing in real time.
Cool. Thank you. We can wait a couple of minutes for some more questions. Yeah, but thank you. Thank you, Gavi. I can also introduce our next speaker, maybe. Alex, I can see you backstage. I don't want to just drop you on the stream if you're not ready. Thank you, though, Gavi. You ready to go? Hello. Hello.
Hi, how you doing?
Good, thank you. How are you?
Yeah, not too bad, thanks.
Awesome stuff. It is a Thursday, so it's almost a Friday, which means it's almost the weekend.
Exactly. That is what everyone is waiting for.
Cool stuff. Right, so we have about 9 minutes before we kick off your session. So as we did with the last session, this is our time to awkwardly stare at the camera for 10 minutes when time comes around. Did you catch up on Build and the Data and AI Summit?
Not the Data and AI Summit so much, but I've been going over some of the stuff from Build, and I think I am equally on the agents hype with Gavi.
Yeah.
AutoGen looks quite fun and definitely something that I am going to be getting my teeth into as soon as I find a chance.
Yeah, it does look awesome. Cool. All right, so we have no more comments. I don't know if comments are coming through on LinkedIn. But yeah, so 8 minutes.
I can always just kick off early unless we want to make AI-related small talk for 10 minutes.
Otherwise, I'm just going to update every minute. Yeah. And if anyone joins too late, we're on YouTube, so you can rewind it back. Good suggestion. So, are you ready to kick off?
Yeah, I am living the one monitor life currently. So let me set up my screen. So I now can't see myself or what I'm presenting, but hopefully you can see my slides and then tell me when I'm presenting, because I will have no way of knowing if I am or not.
Cool. Are you sharing them?
They should be in my screen. Should be sharing in the StreamYard
Cool.
backend.
All good. All right, I'm going to leave you the floor, Alex.
Cool.
Awesome. Thank you.
I'm just going to check the channel on YouTube and put it on my phone next to me so that I can actually see what it is that I'm doing, because this is a very high-tech solution. Cool. Yeah, it looks like my slides are sharing, so I will kick off. So this is going to be sort of focusing a little bit more on RAG implementations and how you can do it using Azure OpenAI. It will touch on some of the topics that Gavi covered in that last talk, but then get into a little bit more technical detail. And I'm going to attempt to do a live demo at the end rather than pre-recording them, so everyone can enjoy when it all goes horribly wrong, even though it worked 10 minutes ago. So I guess the first question is, who am I? I'm Alex. I'm the lead R&D engineer at Hurry, and we make sort of zero-code analytics platforms. And in my R&D capacity, we're looking at how we can AI power everything to do with analytics and sort of platform usability. I've been a machine learning engineer for about 6 years, and I've worked on a whole bunch of different projects, ranging from sort of IoT devices and sports wearables, and looking at how you can implement machine learning there for things like fall detection and sports monitoring. I have worked in potatoes, and anyone who has spoken to me before will know that I talk about potatoes an awful lot. But I did a lot of sort of computer vision there, and also a huge amount of sort of machine learning operations, and actually looking at how you can deploy machine learning applications in real time. And then I've also done some consultancy and worked in kind of various different insurance type industries. And sort of most importantly, I am a converted Gen AI homie, and I've been working on industry Gen AI projects for approximately a year, which, considering ChatGPT and the general AI buzz, sort of came out in November 2022, is a reasonable amount of Gen AI as a field in its life cycle. Yeah, so let's get kicked off. I have a brief agenda slide. So I will start with a very short history of artificial intelligence and generative AI, because everyone says Gen AI and RAG and throws all the terms around to the point where not necessarily everyone knows what they mean or understand it. So I will kind of cover that in brief just to get everyone up to the same page. I will then immediately jump into everything that's wrong with generative AI, what some of the limitations of large language models are, and then get into the good stuff, which is a little bit more detail around what RAG is and how it works. I will then cover the sort of core components of RAG. They are very much the core components in my opinion. There's a whole lot of stuff going on in RAG, but I'm going to try and break it down and make it as simple as possible. And then finally, I'm going to talk about how we can build and pretty much get into a deployable state, a RAG implementation. And that's going to be looking at using Azure OpenAI, AI search, and then also LangChain in the background to pull it all together with a guest little spot from Streamlit, which is a nice little sort of Python web application platform that you can use. And I will also have some silly memes dotted about the slides because I think they're funny and no one can stop me. So first of all, we'll jump into a quick history of AI. So artificial intelligence as a field came about in roughly the 1950s and was generally just, can you get computers to think and act as well as or better than humans in terms of their levels of intelligence? And a great example of the first sort of AI application that really caught my eye is something called Shaky the robot. So Shaky the robot was essentially a autonomous navigating robot, and he got the name Shaky because AI technology back then, he was essentially reevaluating the path that he was following to get from point A to B every second or a few times a second, to the point where he'd be constantly making slightly different decisions and would just shake about whenever he was moving, getting the adorable little nickname of Shaky. And that was sort of the field of AI for quite a while. Things like perceptrons and neural networks were kind of hypothesized and theorized, but the technology wasn't quite there to really try them to their full potential. But around 1997 is when machine learning kind of took off. So with the big field of AI being problem solving, machine learning is a sort of subfield of artificial intelligence, looking at taking and learning from existing data and improving on that data to either make decisions or to make predictions. And so there's kind of where your traditional machine learning algorithms come in, like linear regression, support vector machines, random forests, everything like that. And they sort of bumbled along very nicely for a few years. They became quite powerful, and it's a sort of, I guess, referred to as traditional AI now, which makes me a little bit sad because it's only a couple of years old and still extremely powerful in a lot of cases, but everyone loves their deep learning and their generative AI. So deep learning sort of came to the forefront roughly mid-2010s. There will be people who go, oh, I've been developing neural networks since 1999. But when things like PyTorch and TensorFlow sort of really came to the forefront, and there were lots of technologies around that, and things like YOLO for computer vision, is when deep learning really took off. And that is using neural networks, which are essentially deep models, which have multiple layers of neurons all stacked up, and they can make sort of very big and informed decisions. And then within deep learning, you have the field of generative AI, which has sort of taken off in the last couple of years and is definitely all the rage currently. So we then have another very similar diagram, as generative AI in and of itself is a very large field within AI, within machine learning, within deep learning, which is creating new written, visual, and auditory content given prompts or existing data. So it is taking AI and making it create something new. So with a traditional machine learning model, you might give it a load of data on iris plants with their petal and settle lengths and widths. That is a mouthful. And it will predict what species of iris it is. Generative AI is saying, draw me a picture of an iris, and then the model goes away and it creates something new, which is the picture of the plant, or it is kind of classifying them and generating new information. Within generative AI, the models that are used a lot of the time are foundation models, and they are large machine learning models which have been pre-trained on huge amounts of unlabeled data, and then they can be fine-tuned, as Gavi discussed previously, to be better at more specific tasks. And then a type of foundation model, and the sort that I'm going to be focusing on today, are large language models, which are these foundation models, but specifically designed for natural language processing tasks. So they're things like your GPT models, your Falcons, your Mistrals, all of that good stuff there. So now that we have sort of covered the basics of what AI is, what Gen AI is, we're going to kind of double down into large language models. And first, I'm just going to talk a little bit about what they can be used for. So I'm going to go from right to left, even though my diagram goes left to right, because I think it's easier to talk about the sorts of things you can do with them and then the data that's required. So the answer is honestly a whole bunch of stuff, more than just the 4 bullet points that are on the slides. But some of the key use cases and things that can really bring value to businesses very fast are things like question answering. So building chatbots for your sort of websites, applications, anything like that, that are actually smart, actually able to answer questions and have a little bit more sort of oomph to them outside of just taking Q&A pairs that previously existed, going, yeah, this seems to be about the most relevant QA pair. I'm just going to give you this answer, even though it doesn't necessarily matter. They're great for sentiment analysis. So if you have a whole bunch of text, you want to know how your brand is doing, you can scrape a load of tweets, do sentiment analysis, and get Gen AI to tell you if people like you, hate you, or are indifferent. You can extract sort of relevant information. So if you have huge legal documents which are full of a load of jargon that you don't quite understand, you can pass them into a large language model, and you can get the key bits extracted and then also summarized so that you have a nice little couple of paragraphs to feed back the general gist of what these huge documents say. And as to what you can feed in sort of blogs, technical documents, call transcripts, the traditional QA pairs from old school chatbots. If you have a vast amount of information in your company's emails that you think would be useful to the whole company, you can feed in a load of emails and then build yourself a nice little chatbot to answer questions internally based on all the information that's shared and not necessarily published. So now we are going to get on to a particular use case for large language models. So there are a ton of sort of big business use cases like, understanding all of the technical documentation if you have a very large factory, or if you have a very sort of complex tool that you want the users to understand, you can build a chatbot based on your internal sort of technical documentation knowledge base. But for today, we are going to talk about a man named Robert Goodman, who is this fine fellow with the ginger hair and the mustache here on the screen. He is one of my characters in a tabletop role-playing game called Lancer. And he is a great example of someone that doesn't exist on the internet. No one can possibly know about him. Chatbots can't answer questions about him because he doesn't exist outside of a few documents that live predominantly in my Google Drive. So he is a fictitious piece of information and a great example for something that a model wouldn't necessarily know about up front. So we can go to ChatGPT and we can ask him who Robert Goodman is, and he will tell us a load of rubbish. He is not from Code Geass. He is a made-up character I have created. So, ChatGPT in its raw form is wrong, which brings us through to the biggest limitations of LLMs, which are hallucinations and the fact that they don't know what they don't know. So you can see that ChatGPT gave its best answer about who he was. It was completely wrong. That is not who he was. But it gave an incredibly detailed and sort of very believable answer to the question, even though it was talking complete rubbish, which is one of the issues in that you can get uncontextualized data, ungrounded data, feed it into a large language model, and you'll get an answer back that presents itself with a high level of confidence, even if it is factually incorrect, irrelevant, or just complete and utter nonsense. But there is an easy solution to this problem, and the way we teach our LLM about Robert Goodman is through RAG. So what RAG is retrieval, augmentation, and generation, or retrieval augmented generation, any sort of combination of those general words, and they are the 3 steps. It is sort of along from, zero-shot prompting and few-shot prompting. It is one of the 2 ways of giving information and context to a large language model so that it can answer questions with more factual information and with a higher level of confidence. Fine-tuning is a very similar way of getting the same sort of responses. And although fine-tuning is getting easier and easier to do, it is computationally very expensive. And for the vast majority of use cases, unless you're kind of have tens of thousands, hundreds of thousands, millions of documents, you can get a very fast, very accurate solution by using RAG. And so the way RAG works is in 3 simple steps. Step 1, you get the information from a database that relates to the question that you asked. This is where vector databases come in, because you can embed and store all of your documents in a database, and then you can get very, very fast, very, very accurate searches on what are relevant documents from that database. You can then augment your initial prompt with these documents from the database and this sort of context-specific information, combine them together, and then generate an answer to the question that has context and is grounded and actually gives you meaningful information. And there's a few sort of tips and tricks along the way that you can utilize to make sure that it doesn't spit out rubbish and that the model doesn't hallucinate. And we are going to sort of cover the architecture first. I'll then cover the core components, and then I'll talk a little bit more about the practical applications and how you can implement it and show off some code and fun stuff like that. So the overall architecture in a very basic form of a RAG implementation looks like this. So I'm not sure if my mouse is visible on the screen. I don't think it is. But in the top left, you can see we have the user who is asking the question, tell me about Robert Goodman. And so he then feeds that into the system. That will be embedded. So that will be essentially vectorized and turned into these multi-dimensional arrays and vectors so that they can be passed into a semantic search, hybrid search, keyword search, whatever type of search you wish to use, into a vector database, which has all of your documentation. And in this case, all the facts and the info and the life of Robert Goodman stored in this vector format in the vector database. It can look up the most relevant information from that vector store and then return it. You can then combine that with the initial prompt and pass the whole thing, your question and the information with the answers contained within it, to a large language model, which will generate you an answer, and you can then display that back to the user. And in this case, we get that he is a red-headed space farmer from the planet Eden Kappa. Most of that sounds like gubbins because essentially it's all made up, but our LLM knows about it and it can answer the questions correctly with confidence, which is a step above essentially hoping ChatGPT doesn't hallucinate too badly. So looking at the core components of a vector database, not of a vector database, looking at the core components of a RAG implementation, you have a large language model. You need something that is going to be able to take your information, your prompts, and then generate you the answers to the questions. Large language models are the absolute peak of NLP currently, and they are a fantastic way of doing this. And there's a whole bunch of them out there. There's sort of your OpenAI models, your GPTs. Meta have got the various Llama models. There's Hugging Face models, and there's a whole bunch out there to choose based on the different use cases and sort of their different strengths and weaknesses, which are generally things to do with speed, the kind of power and performance of their implementation, and then also cost is a factor as well, whether that's the cost to host, the cost to use them through an API, anything like that. You then need a vector database, which is a database which stores high-dimensional vectors and the mathematical representations of your features and attributes in your data, which can be searched very quickly with a high level of accuracy. There are a whole bunch of them out there. Kind of the three that spring to mind, and I think are the most powerful, are Azure's AI Search, ChromaDB, and Pinecone. There are a whole bunch of other ones out there too, which all kind of have their merits, but those are the three that I think are a good place to look at for a starting point. You know, there's always sort of pros and cons to all of them, but if you want a vector database to take a look at, there's three to kind of have a little bit of a play around with, and I think that one of them will more than certainly fulfill kind of all of the vector database needs that you have. And then finally, it's not really a component. It's kind of a slightly wishy-washy science. Some people would argue it's just speaking English, it's just grammar, but also prompt engineering is very important in RAG because you need to get your model to use the data in a meaningful way and to actually produce an output that you want. And give information in a way that's actually useful to your user and your use case. You could just feed in a question as the kind of user prompt, do the vector database lookup, and then let the LLM run wild, but you're likely to get very inconsistent answers. You might not get the format you want. It might start spitting out information you don't necessarily think is necessary. So prompt engineering becomes even more important in these RAG sort of implementations due to the volume of data that you're looking at and due to the sort of slightly random nature of large language models, but it's very easy to control all of that through a bit of prompt engineering and a bit of temperature control. So I will go over all of these three components kind of in their fundamentals, and then I will talk about the actual sort of technologies and demonstrate how they can be used. So first of all, large language models. They are a specifically designed foundation model for NLP tasks, and they are far more complicated than 4 little sort of bullet points, but in brief, there are sort of 4 main steps, well, two main steps and then an input and an output, which break down how they work. So the first thing you do is you provide it an input. In this case, the input is the description of what segmentation is and tokenization. That is what you would pass into the model. You then have something which will tokenize, segment, and embed your information. So the process of tokenization is essentially breaking text down into much smaller chunks. Sometimes they're sort of a part of a word, a whole word, or a small phrase. And depending what sort of tokenizer you're using, that will sort of make those decisions for you. So you don't have to go through an arduous process of string processing and splitting strings based on punctuation or spaces. You can use something that's a little bit smarter and will tokenize it in a way that is optimized for use in large language models. You then pass this nice tokenized message into the model itself. You might want to combine it with a system prompt. So in this example here, the system prompt is, you are an AI helper designed to summarize text. Please summarize and shorten any inputs you receive. So we pass in the user's piece of text, combine it with this system prompt, and we hand it over to the model, which for this slide works its magic. It is, probably a talk in its own right, explaining how these models work and generate your answers, but they are essentially looking at the probability distributions of what the next word in any sequence of tokens will be, and then doing that in a loop with a lot more complexity and a huge amount of training data to give you an output. And the output in this example is tokens are bits of text fed to and made by AI models. They can be letters, words, or even parts of a word. So essentially what we can see there is how you can take your input text, tokenize it, pass it to a model with a little bit of a system prompt, and then get your output of the model sort of doing its specific task. We then go on to looking at vector databases, which are again another sort of very complex topic. Gavi did a really good job of sort of describing how they work. So I won't go into too much detail. So I have a couple of sort of key concepts here, which are embeddings and similarity searches, and then a very nice diagram, which I stole from a blog by Quadrant, who are another example of a fantastic vector database company that kind of sums everything up and how it works. So embeddings are numerical machine learning representations of the semantics of the inputs of data, and they are really good at capturing the meaning of high complexity data or high dimensional data, because you can have a load of words and you can sort of go, oh, these are similar based on, they've got the same number of vowels in, but that doesn't really capture some of the more complex factors in it. Whereas through embedding into these high dimensional vectors using embeddings models, you can sort of split them up into clusters of similar words, and you have a lot more of the meaning of your words retained. And then also when you are doing a search, it dramatically narrows down the search space which you are looking through. So when you are trying to match, similar things or retrieve relevant documents, it's much faster being able to go to a specific point in the vector database and pull it out from there without having to comb through absolutely every single thing in there and do a sort of comparison one by one. Because when you're having sort of tens of thousands or millions of embedded vectors in there, that would take far too long to be usable. And then the other thing, outside of being a fantastic way of storing data, and I've kind of touched on, is that they are a fantastic way of retrieving data as well. And they excel at finding similar data points, which is crucial for Gen AI and sort of machine learning solutions, as it can get the relative or sort of the relevant information based on meaning and context, not just, oh, this matches, this looks the same, it must be the same, which adds another level of sort of smart to it, overall adding to the AI part of artificial intelligence and improving its ability to problem solve. So finally, we have prompt engineering, or the basics sort of thereof. And the general gist of it is the better the prompt, the better the response. So much like you have garbage in, garbage out when you're looking at data, if you have a good prompt for your LLM and for your system, it is far more likely to give you a response that you are happy with. Now, there are a whole bunch of different approaches to prompt engineering. There's a whole bunch of frameworks and templates. I'm going to sort of briefly talk through the CoStar framework, template, methodology, whatever you might want to call it, which is a kind of set of guidelines on how to design a good prompt to ensure that you're getting kind of consistent, well-formatted answers and responses from your model. This isn't sort of a step-by-step guide, 1, 2, 3, 4, 5, 6. It is a little bit more of an abstract concept, so we don't have a particularly structured diagram. There are these 6 factors that you need to consider when you are writing your prompts, and as long as you touch on them at some point in the prompt, then you know that you'll be able to get a good response from your model. So the first of them is context. Your model needs to know what its purpose is and what it's trying to do. Are you an AI assistant? Are you a funny jokester that speaks only in rhyme? You need to provide the context for what you're doing and what the purpose is. You need to say what the objective is. Is the objective to summarize information and make it smaller? Is it to expand on things? Is it to provide recommendations? Is it to provide sentiment analysis? It needs to know what it's trying to do. You can then sort of have style and tone, which is what is the sort of style of the response and the general tone that you want. Do you want it to be, sort of bullet pointed and very formal, or do you want it to be a little bit more whimsical? All of those things need to be described in the prompt to ensure you're getting that in your outputs. Finally, it is always handy to talk about the audience, because that will very much set the theme for the style of the response. So even a sentence as simple as, you are a AI chatbot used to help non-technical users understand technical documentation. If it has that general gist of who the audience is, it's able to generate responses that are appropriate to them and kind of contain relevant information without going into too much detail that that they won't be able to understand. And finally, examples of the type of response that you want to do. You can provide in the prompt a couple of example inputs and outputs. If there's particular formatting that you want, so you want various different headings, or you want to make sure that it's less than 500 words, or sometimes models, particularly GPT-4o, it really loves to format things as Markdown, which is great if your output is going into a system which can handle Markdown. But if it's going into a plain text response, it can just look messy. So even things as simple as do not format your output as Markdown are great ways to sort of control the response that you get. And then this isn't even touching on things like saying, if you don't get the answer that you want from the context, reply with I don't know. There's a whole bunch of things you can do, but having just a general checklist and a framework towards writing your prompts allows you to make them even better and sort of have your application have the little next step up and the professional touch that you're looking for. And finally, now we've gone over the sort of basics in their kind of theoretical, I guess, form. I'm going to talk a little bit more about the technical stuff. There will be a code demonstration and we can get into the fun bit, as I like to think, because there is nothing better than a little bit of code. So the first thing that we need is a way to use a large language model, which is step one or component one of our Reg implementation. And I'm going to be showing how you can use Azure OpenAI, because it is essentially a fantastic REST API for getting very quick, very controlled access to all of the OpenAI models. And also through using things like AI Studio, you can have one place to have your Hugging Face models, your OpenAI models, your Llama models, a whole bunch of choice, because more options is always better. And then the vector database that I'm going to use is AI Search, because that is a very fast, very powerful vector database. It has hybrid search functionality, which allows it to do keyword and semantic search at the same time, which is just sort of boosting the performance of the search. And also the Microsoft sort of suite of AI services work really nicely together. They're kind of all underpinned through AI Studio and various AI services. So if you stick in the sort of Microsoft boat, you can leverage things like, AI services. So things like document intelligence, the models that they provide, all of the various things that were in cognitive services like Translate before it got renamed. So it kind of makes sense to use. And then finally, you need a framework that you can use to sort of orchestrate all of your steps and actually build the application and the flow and the logic. And LangChain is a fantastic tool for doing that. It's very well established. It is documented beyond belief, and it's also completely open source. So it is a great tool that you can use, but there are other alternatives. You could just use PromptFlow. PromptFlow is a great way to do sort of prototyping, rigorous prototyping, evaluation. It has some deployment options through the sort of real-time deployments, but you get a little bit more rigor if you're using something like LangChain through being able to containerize your own applications, build them into other things, and having a little bit more flexibility. And then I am going to use Streamlit, which is hiding up in the top right corner to just sort of tie all of this together and be the very simple web front end for the chatbot that I am going to build. You can build this into any other, you could build all of these into function apps or fast APIs and have them as an API called from a traditional sort of React web front end, but you just get a lot of choice, and Streamlit is the fastest and easiest way for a web development noob like me to actually pull something together to essentially demonstrate and show off. So now we get to the fun bit. It's never that exciting watching people sort of scroll through Visual Studio Code, so I'm going to do my best to keep this reasonably brief, talk about what is going on, and then we will go into a live demo. Oh, there was actually a slide on that with another funny picture. Yeah, so what I'm going to cover in the demo, I was going to cover AI Studio and embedding data and creating indexes in AI search, but Gavi has done that already, and her demo was pre-recorded and far cleaner than mine will be. So at the last second, I've struck that off the agenda. But the next thing that we're going to do is create a RAG implementation using LangChain. The word flow is there because it was going to be prompt flow, but now it's LangChain. We're going to connect all of the relevant services. We're going to do a little prompt engineering, and we're going to get a good answer to the question of who is Robert Goodman. And as my little picture shows, nobody says anything, but there are always problems right before the demo, including the fact that you noticed typos in your slides. Hopefully there were none of them before, but if there were any, please don't call me out on them. So jumping into the code, we have the standard block of imports at the top of any piece of code, which the vast majority of these are all importing from the various different LangChain services. We've got LangChain OpenAI, which is going to handle the embeddings model and the chat models. We have the vector stores, and we're using AI search, which will handle all of the sort of connection and querying of our vector database. And then we have a couple of little utilities like the output parser and the chat templates, just to make things sort of clean and nice and simple. And then we've got a couple of libraries because I wanted to put images on my website, so we use those there. You might notice a very weirdly out of place environment variable set just there. That is because there is currently a bug in AI search, which is where it will default the content vector field name to content_vector all lowercase. Somewhere in their code, it will set that environment variable. So if you don't have a content vector in your fields of your vector database, it will never be able to find it. So before you import the AI search library, the Azure search library, you need to set that yourself to the name of the content vector field in your vector database. That was allegedly fixed about 6 months ago, but it still doesn't work. So if anyone from Microsoft is watching, there's a bug fix that needs to be done. And scrolling through the code, there is someone who has just left a line almost identical to that one in the Azure search code, which just sets it to content_vector. From there, we get into actually setting our own environment variables. So the only things that you will need to do if you are using a .m file or you have environment variables set in your container, these two lines are superfluous, but because I'm running a sort of very lightweight demo, I take information stored in my secret management, which for this is using the Streamlit secrets management, and then I just set them as environment variables because the various functions that I want to use for OpenAI will pull the environment variables in. You don't have to set them in the code. So I set those there. I then set some paths and load some images to make my Streamlit app look pretty. And then we get into some of the implementation of building a chatbot. So the first thing that we want to do is essentially we want to create the messages that our chatbot is going to display. This is done by using a session state variable, which means that it will persist. So it will not overwrite itself anytime you add something new. You don't need to worry about constantly and iteratively going back over old messages and adding them to a variable. They will essentially persist in the web app, and we set it off with a assistant role message, which just says hello and introduces themselves in a fun and quirky way. We then get into sort of model loading, which is getting into the good LangChain stuff. Let's see if I can shrink my terminal anymore. Yeah, oh, that may be gone forever, but that's fine. Which is where we are going to create our connections to the various models that we want and to the vector database. Again, this is done as a session state variable so that you don't need to constantly connect to the vector database every time someone makes a call. And it means that if you are hosting this and there are multiple users, you are saving a huge amount of compute and time because you're not constantly making the same calls with the same data. So using LangChain is incredibly easy to do because there is the Azure OpenAI or the Azure Chat OpenAI function, which will allow you to connect through to your model. It will pull the key and the endpoint from the environment variables, so you don't even need to define them here. Then all you need to do is tell it what what API version you're using and what the name of your deployment is. You can hard code them in. They're not necessarily something that needs to be kept a secret, but by having them in the environment variables, it makes it a little bit easier to change them in a deployed app rather than going, right, I've changed this variable, time to dig through the code, change everything. If you're deploying a new model, you don't want to have to be digging through your code, making sure you change all the names, forgetting one of them somewhere and going, can't remember which file I didn't change the name in, but everything's broken. You can know that you have a single source of truth for these things, which are your environment variables or your secrets. It is exactly the same for the embeddings model. Doing that there. And then finally, you can connect to your vector database, which is Azure Search. And this time you do need to pass in the search endpoint, the API key, the index name, and then also an embeddings model that you want to use. But fortunately, Azure Search will handle embedding the plain text input for you. So you don't need to do any of that stuff. You can just go, cool, I have some text and I want to do a vector search using it. Pass it into the vector search, it will embed it for you, do the vector lookup, and then respond with plain text, which is fantastic. So then we get on to the sort of two key functions that make up the entire thing, which is doing your vector search and calling your model. I've split it out into two separate steps. You can do it all in one chain using LangChain. It can be a little bit more efficient and it allows you to run some steps in parallel, but it is a little bit more difficult to understand, and there isn't that much of a loss in quality by splitting it out, doing them one after the other, and then sort of joining it all together. So quite simply, all we do here is we have a function that takes a prompt from the user that they will input in the chat box. It will then take that session state variable of the vector store and it will perform a search. You have the ability to set how many documents you want to look up, whether that be 2, 3, 5, 10. You can kind of control it. The fewer documents you use, the more likely you are to focus just on the key and the best responses. But if you have quite small documents, or you know that your information is spread out between multiple different documents, you're likely to miss some of the other important documents if that is too low. And that is just a sort of value that you can tweak and tune when you're developing your application based on the inputs and the data that you're using. That will then return an object of documents. And all I do here is simply go through all of them, just extract the page content, so what's written in them, ignoring any metadata, and join it all together in one big string. It's not necessarily the most optimal way to do it, but it is quite an easy and robust way to make sure that you take everything from your documents, get it in a big block of text so that you know that your model is going to have all of the relevant and contextual information. And this kind of makes up the RA part of RAG, which is the retrieval and the augmentation. We then get into the calling of the model. So what this takes here is, again, the user's prompt. The prompt was used before to look up the relevant information, but it's also needed in the model call so that you can actually refer back to it and answer it appropriately. And then we need all of the data that has been retrieved. I am using LangChain's LCEL here, which is essentially a very nice way to get very simple, easy to understand prompts, which are very code readable. So if we look at the chain that I have there, it contains 3 steps. It contains a prompt, it contains a model, and it contains an output parser, which essentially says, I take something, I pass it to a model, then I format the output. We then have the prompt here, which is very simply, you're a helpful assistant designed to answer questions. That isn't following the CoStar framework. There is a huge amount of information that is missing, which we could do a little bit of prompt engineering on. We could specify the format a little bit more. We could make some conditions. We could set the tone, but it will generally do the job. And then where you get the sort of augmentation is here. So you're asking it, please answer the following question, and you pass in what the user has given you. And then you say, using the information provided, which is your retrieved information there. And then when you call and invoke that chain, you are able to pass in the user prompt variable and the information variable. You can make this a lot larger. It doesn't just have to be a user prompt and retrieve data. You can feed in all sorts of stuff. So if you are pulling, data from databases or dashboards or analytics tools into your application, you can feed all of that into the prompt and give the model an incredibly contextualized picture of everything that's going on. It'll have all of the information that it needs to know, and it will be able to give you very high quality answers on information that otherwise isn't available to it. And then the rest of this is just a little bit of Streamlit code to essentially build a chatbot. So there is a section here, which is, because of Streamlit's incredibly readable and easy to write formatting, a subheader and a title, which are my name, in 2 separate columns, and then a picture to go next to it. We then have something that is going to write out the contents of the chat, and then we create a chat input button here using the walrus operator, which is essentially taking the contents of it and checking that it has occurred. It will output the question the user has just entered into the chat window, and then it will retrieve the documents, create the augmented response, generate the answer, and display that there. So if I double check my terminal, we can see that my application is running. So if we jump back into my web browser, we should be able to see the Robert Goodman RAG chatbot. So if I hit refresh there, you'll see that it very quickly loads all of the models and makes the connections to the vector database. So we only need to do that once, and then we are good to chat. So here we can now ask questions that ChatGPT and other models won't know the answer to, like how old is Robert Goodman? It will have a little think, and it will tell us that Robert Goodman is 37 years old. I know that to be correct. I could pull up the document and prove it all to you, but you'll have to take my word for it. But we can then answer some more intricate questions. So where is he from? Yeah, and then it will tell us that based on the provided that he is from Eden Kappa, and then we can ask what are Robert Goodman's beliefs, if I can spell, and it is going to give us a little bit more information on the weird and wonderful things that Robert Goodman believes. So here we can see that it can pull out a little bit more information from the embedded documents, and what it is going to say is that he has 3 core beliefs. One is that each planet in the universe has a soul, which can feel pain and joy, that there is a group of sentient crows who secretly run the entire world, and that traveling through blink gates or teleporting creates a clone of you in your new location, and then your old clones become enslaved. So he is clearly quite the tinfoil hat wearer and a little bit of a zany person. But in short, that is how to build, implement, and then short of creating a Docker file, turning the Streamlit app into a container and hosting it on something like app services, you have an end-to-end fully implemented RAG project. So I'm not sure if I was due to finish at 7:30 and have run over by 2 minutes, or whether I have been good and have finished a few minutes early in time for questions. But thank you very much for listening. And if there are any questions, stick them in the chat. I'm sure Tori will tell me what they are, because I can't really see anything. Hopefully you now have all of the skills you need to build a RAG implementation and become a Gen AI master in no time at all, using a mixture of AI Studio and LangChain.
Oh, thank you, Alex. Always enjoy listening to you talk about such things. Okay, got some questions. So question I want to ask is, how does RAG deal with like tabular data? So when you got things numerical.
So you have sort of a number of choices when it comes to numerical data. One is you can essentially just feed it in a reasonably raw format and hope for the best. Newer versions of sort of large language models are actually quite good at understanding numerical data in the format that they come in. So you can, feed in like a time series bit of data and say, what do you think of this? And it will have a reasonably good stab at sort of identifying basic trends. You could also go a little bit more advanced and use something like function calling to essentially call out to some more mathematical functions that you've defined to do a little bit of the analysis up front, and then essentially feed that back in a condensed format back into the prompt, which can then analyze that as is a little bit more text-based and give you a slightly better answer.
Nice. Cool. Thanks very much. We've got someone else saying, what is your top 3 recommendations to become a Gen AI homie? I wonder who that is.
Recommendation number 1 is accept that traditional machine learning is traditional, and that actually there is a ton of cool stuff you can do with Gen AI that you can't do with old school machine learning. And then number 2 is pick one tool and just have a go with that first. It's easy to sort of look and see, right, there are 10 different models I could consider, 50 different vector databases, 1,000 different frameworks. They all look really hard. Even if it's just sort of eeny, meeny, miny, mo, pick a model, pick a vector database, pick a framework, and just sort of roll with it. You'll be surprised how easy it is to build something very cool in a short space of time. And then once you've sort of built a couple of applications, you can then go back and start to critique all of the steps along the way and make more informed decisions. But just actually doing something is definitely a good first step. And then the third step is definitely be peer pressured by your colleagues to start looking into it, because they are right and you are wrong when you are skeptical.
Oh, nice one. Okay, we're running a bit late, but I think we've got time for one more question. So someone's asked about costs. So if it's possible to touch on costs for setting up these projects.
Cool. Yeah, so that is a great question. It's a difficult one to answer because it depends on the implementation that you go for. The costs can be very low. So if you're using sort of Azure OpenAI and like a GPT-3 model, they have very, very low costs per token and they're pay as you go. So you don't need to worry too much about sort of racking up massive bills using an API or doing any fine tuning. Then, you know, touching on things like deployment, Streamlit can be very, very cheap to deploy. You can very easily containerize the application. LangChain is open source and free, so there's no overheads there. And then you can host a containerized application in sort of an app service or any sort of Kubernetes orchestrator and have quite a sort of cheap front end and deployment there. Where costs will come in are around vector databases. You can avoid costs by using something like ChromaDB, spinning it up yourself, and then also hosting that in Kubernetes or equivalent, for essentially very minimal overheads, quite a cheap implementation, but you have a lot of issues with having to do all of the sort of scaling and load balancing yourselves, all of the sort of DevOps and things like that. But then if you want to use sort of a lot of the serverless kind of options available, kind of go down the AI Studio route, it can be quite expensive, but then it becomes a lot easier to sort of work on and do, where the time cost is reduced because they're a fantastic tool for doing things very quickly, but the monetary cost is a little bit higher because they are more expensive to use.
Nice. Oh, thank you. Okay, I think that's all the questions we've got time for. But yeah, thank you, Alex, for joining us. Yeah, very good talk. And hopefully this is not the last time we see you for your lovely talks.
Cheers.
Thanks, Alex. Okay, thank you everyone for tuning in. If anyone has any interest in speaking at these, please feel free to drop a message to myself, Gabby or Tori. Also, just want to make sure that to check out the Meet group for the next time we do this. So we're looking to do one in September 19th. So please keep your ears close to the meetup to see what happens. And thank you very much for joining in and enjoy the rest of your evening. See you later.